Good. Okay. Thanks. Thank you for the kind words. And I guess I've been challenged, and hopefully I live up to the challenge. So yes, I guess I have 1 foot in two worlds, or sorry, 1 foot in two separate worlds. 1 foot in the research at an academic level at CIMS, and one foot in the world of architectural practice as a partner at If Then Architecture. Okay. Sorry, I don't see the slides advancing in front of me, so I keep looking up. As Stephen, I guess Steve gave a pretty good introduction as to what CIMS exactly is. In the center is the scanning and in BIM of the center block. And on the bottom right, kind of where the kind of eponymous CIMS came from, the immersive environments. And the research that I've been heading up, and one of our most recent, is the robotic milling and what we call digitally-assisted fabrication, which I'll try and define more specifically in a minute. I'm just going to see if this video works, but this gives you an idea, if I have to hit play here. So this is the smaller of the two robots that can mill softer materials such as wood and foam. So, kind of in the vein of prototyping and mock-ups and things like that. Right now, this is a crown that it's milling from the Arms of Canada on the West Block. This is the existing condition, and this was a project that we worked with the stonemasons on, where we could provide that existing condition, and then they could go ahead and plan their repairs using modeling clay, and then the actual stone carving. And then the larger of the two, let's see if I can, there we go. So this is the bigger, this is quite a large robot. It's a KR360, which designates that it can lift 360 kilograms. That's not really our application, but nonetheless, it's a very heavy-duty robot. And you can see this is, again, the same crown in Berea sandstone, which is the sandstone that most of the sculptural elements are carved from on Parliament Hill. And generally, the typical workflow that we've been using in the masonry realm is that we can use the robot to do roughing, remove a lot of the material, and then the masons can come along and add detail and the kind of final touches by hand using the traditional technologies. And again, as I said, I'm a partner at If Then Architecture. Kind of one of our kind of initial offerings, just to get us kind of out in the marketplace, is terrestrial laser scanning. So we have a Leica P40. This is a laser scan of an indoor water park that we did as well. And what, again, kind of right now, we're offering laser scanning services, but ultimately we see the laser scanning as something that is not kind of a service or product in and of itself, but something that facilitates something kind of more advanced processes. This is again an example, quality assurance. This is a concrete slab that we scanned. There was concerns about the deformation in the slab, so being able to quickly understand whether that concrete slab was poured properly. And as you can see, there's a lot of variation. Another kind of interesting application that we've gotten into, I say serendipitously, this is a scan in and around the area of City Hall. I don't know if this has have a laser on it. You can see, you can make out City Hall to the top right, the courthouse to the top, over to the left. And the whole purpose of this was we were working with government researchers to come up with a simulation model to understand how 5G wireless technologies work. They behave very differently than other wireless technologies, and this is one of the areas of research is for driverless cars, or not research, but applications for the 5G wireless. So again, we're trying to kind of branch out beyond just the stereotypical architecture firm. So now to the talk. This is internet cakes. It's a what do cakes on the internet have to do with architecture? So I have two examples that they're kind of humorous examples here. One of them, there's a meme out there called Nailed It, where somebody who obviously does a very poor job at something, and someone says, you know, that you nailed it. But nonetheless, this is often the way I feel that architects kind of view the world and how their buildings come into realization. On the left is this kind of idealized platonic design of the Cookie Monster, and then in reality what happens. And you know, architects like to blame contractors and everybody else for a lot of these issues. The second one, if you read it, best of luck in the Windy City, and obviously this is the instructions that were not meant to be written on the cake, have Windy City italicized like it's blowing in the wind, and this person took it quite literally. But I honestly see this as a kind of a humorous example of what happens on a lot of construction sites today. If you've ever been to the grocery store, you see these pre-made cakes in the counter, and then you ask somebody to actually customize that cake. And that's very much what happens today on a construction site. There's millions of mass-produced components, studs, drywall, floor tiles, everything. They come to the site, and then we expect everybody to perfectly customize these mass-produced objects with or without maybe the appropriate skill level or the appropriate amount of communication. So you could just imagine how a drawing would communicate this. This is almost as if this is something that was built purely by specification without a drawing. And digitally assisted fabrication, just to define it how we see it at CIMS, and this is kind of an example of how we do not see digitally assisted fabrication. Now, with a grain of salt, this is an art project, not necessarily a serious project, but nonetheless, the intention is to remove the human out of the equation, and that the human is only really required to supply the clay and not actually have much input into the work, that the robot does the kind of creative work and that the human is off to the side. And that's kind of the antithesis of the way we see this digitally assisted fabrication. So the kind of, you know, maybe our most famous example is the East Block rehabilitation work that we did with Phil White. And there was a relief sculpture that was identified. This is an owl that is on the north facade of the East Block. This is the existing condition that it was in. It's been face bedded, so the bedding lines of the sandstone are in vertically as opposed to horizontally, which they should be, and so over time it's delaminated. So it was identified to be replaced. We worked with the Heritage Conservation Service of Public Works to digitize it. So this is a polygon model of that existing condition. And then we cut that on a CNC router here at the School of Architecture. And if you notice, I'm kind of skipping a step here, but if you notice the detail on the owl here versus the detail on the owl here, and that is, we cut that existing condition on a CNC router and then provided that to Phil White, who's the Dominion sculptor, who also works, not now, I said Public Works a few minutes ago, but it's Procurement Canada, Public Services and Procurement Canada. Phil White's an employee there, and he does all kind of important sculpting projects on the hill out of wood, out of stone, bronze castings. Sometimes he does them by himself, using his own hands, and other times he does the design and has someone else do this. So the work that you see, the detail that's been added, is actually the work of Phil with clay. And just some things to point out, you can see the existing tooling marks, the kind of horizontal lines that are running up there. That's from the original stonemasons, and so that gives us an idea, it gives Phil an idea of how this thing was actually made in the early 20th century. Just some more detail of Phil's amazing handwork. And then just a comment that, you know, sometimes these digital processes, when you're, something that we often talk about in connection with this digitally assisted fabrication is a notion of craftsmanship, a digital craftsmanship. So yes, we're using these seemingly automated technologies, but at the same time, if you don't take that same kind of mindset about craftsmanship into the world of the digital, you can get results like this. And this is at a time when we, you know, maybe we're a little more inexperienced and there's new software. But you see the artifacts, the strange textures, those were actually introduced by the digital process and not actually reflective on the stone. And that's in that top area on the left, so just kind of bad data that, again, this was a process at the time that we were just learning. And you see this is a close-up of that polygon mesh, and it resulted in more kind of strange artifacts when we actually output the object on a CNC router. And again, all of these things were ultimately rectified, mainly through the knowledge and skill of Phil, but nonetheless, we think it's very important that even though it's digital work, that there's still this strong sense of craftsmanship involved. So once Phil applied that layer of clay by hand, it was digitized a subsequent time. And so this is a polygon mesh model, a computer model of that, what we would call a virtually restored carving. And then this was a test with the robot, and this is not actually the robot that we currently have, but at the time, this was near the kind of Kitchener-Waterloo area. So this was a test in foam. And then we made the jump to stone using the same robotic integrator, and there was some trials and tribulations, and this is just kind of a process of how it came to be. And that's the final product from the robot. And again, if we had more time, I could just talk about this image for probably a couple hours, but there's lots of mistakes. The robotic integrator was not experienced, and again, this idea of craftsmanship and taking care in our work. But the intention all along was this is the end product with the robot, but then it moved along to back to Phil White. And on the left-hand side, you can see his hand carving, and on the right-hand side, the carving from the robot. And I've shown this image many times, and I always say the same thing, that it doesn't actually do it justice, that Phil's work just brings the stone to life at a level that you can't appreciate until you see it. And you can see the kind of work by the robot on the right-hand side there. And then this is some work from the Government Conference Center, as Ezio alluded to. And again, this is with Phil White, another PhD student, Ken Percy, and the architect of record are Diamond Schmidt Architects and KWC Architects in Ottawa. But this one is a little bit different in that at this time the architects are involved from a kind of design perspective. So these are the kind of conceptual images provided by the architect of the new Senate chamber in the GCC. And the two that I want to draw your attention to are the doors with the maple leaves on it. And then down below there's glass with, it's hard to make out, but with the leaves on it there as well. So the intention is that, that Phil would carve 12 species of maple leaves. And then these maple leaves would be digitized and they'd be used throughout as a kind of motif throughout the Senate, using casting them out of wood, or sorry, casting them out of glass, carving them in wood, in patterns on carpet and things like that. And our role in this was to kind of facilitate that and help explore what the options were. So these are the hand-carved leaves by Phil. So again, it's not just a matter of finding some leaves and scanning them, like going out into a park and scanning them, but these are kind of highly crafted and well thought and designed leaves. There's kind of a consistency to them, quite detailed. And again, this is hand carving in foam. And then this is the digitization, so this is a polygon mesh model. So the importance for this project was to get that, to capture that hand kind of detail that that only someone like Phil can do. This is all 12, these are the scans. And this is the robot at CIMS carving away at it's kind of a funny picture, this giant robot carving a small piece of wood here. But these are just some of the initial tests that we were doing. And the intention here, a little bit differently, was that the ultimate output would not be by hand. So in a way, it's kind of the inverse, starting with Phil's handwork, and it would be ultimately output on a CNC or robot. These are just some tests, so it's not quite enough detail. We discovered that the root of that was actually the laser scanner. So we went back to the Heritage Conservation Service, and they digitized them subsequently with photogrammetry, a little higher detail. More tests, and then these are kind of some of the final outputs. And this was the final mock-up that we provided, which will be then provided to the fabricator as an example of the level of detail. As well, we'll be providing digital files to that same fabricator. So this is what the Senate chamber door will look like. This is a 2-foot by 2-foot mock-up of that door. And then I'm going to show just a couple projects, maybe a little bit where people on construction sites are maybe a little bit less skilled than someone like Phil White. This is a condominium condominium at entrance lobby at a condominium in Ottawa, the Merit. This is the building itself was designed by Barry Hoban, but Charles Fort would reserve a lot of the design of significant spaces for themselves. So Charles Fort themselves designed this lobby. And so it became a matter of how can we achieve some of the things that they were concerned with, the precise curves and the doubly curved surface. And there was actually nobody in town at the time, this is a few years old now, that was willing to do this doubly curved plaster ceiling. So as a starting point, scan the space. This is all concrete construction. This just kind of gives you a better image. There's surfaces, mechanical surfaces in the ceiling, some plumbing. And then this was the grid that we came up with, a plywood grid. And then as with many projects, it started out, okay, we need this doubly curved surface, but then it became more about making sure that there was an appropriate lighting effect from this indirect lighting. And then what about this grill, the HVAC grill that needs to go around? So all of these things were digitally fabricated. I could mock it up with a model first. All the parts were, again, when it was fabricated by the CNC, all the parts were numbered. And so it was more a different kind of sequential construction, less about plans and sections. And again, we accommodated for those services. And as well, there was a requirement, they were concerned with these walls, that the walls would not be curved, like kind of a nice, precise curve. So the top and bottom plates of the walls were actually CNC routed, and then that provided a substrate for the metal stud guys to come along and build their metal stud walls on top of that. And then the grill, the metal grill that they have this, again, they wish that they could work with someone like Phil White, but in reality, they don't. And so we used a water jet cutter to cut the grill. And this was a mock-up. They wanted to test if we could score it or if it was just cutting. And typically when you use a water jet cutter, it's a through cut. It's difficult to get scoring, but we can override the system. So this is that. And then ultimately, again, in a kind of strange similarity, the finish of that doubly curved surface is a hand-applied plaster finish, and this was kind of that finished lobby. The last thing I'm going to show is a visitor's welcome center, and it was not a collaboration with the architects. The architects for the project are IBI Group and Moriyama Tashima, but we were contacted by actually RJW stonemasons. Obviously the relationship that we had developed with them through CIMS. And for those of you, I guess Ezio's project kind of set the context for that. But it's just north of the West Block. And one of the interesting things for that Welcome Center is that it's integrated into the Vox wall. There's this Vox, he designed the kind of grounds and landscape, and there's a lot of retaining walls and things, and so that the entrance was going to be integrated into that wall. So this is the concrete in that position. And the reason that RJW approached us about this is because of the required precision. I'm not sure that I don't exactly recall what the clause was in the contract, but there was a certain requirement for them to take over all kind of liability for the precision for whether the stones would fit. And I know that in advance of the project, there was some consultation with David Edgar, who is the mason and the architect, to understand the requirements of a stone arch. But nonetheless, as is kind of a typical thing on a construction site, the result is not exactly what was envisioned. So, for example, how the arches were poured here, if you were to actually draw those arches as a traditional mason would, with spring lines and centering of radii and things, it doesn't quite work out. So they were interested in getting that accurate, and they suspected that it would take them probably up to 2 weeks to actually measure the location of the arch, and actually it would be kind of like a medieval exercise, and that they would etch out the plans on the ground beneath, and so instead they approached us. And we scanned it. This gives you another idea. There's two. So the one on the right is a doubly curved. It's a compound arch. So it's curving in plan and curving in section. And on the left is a more simple arch. So these are the laser scans that we provided. And we did it at a very high level of resolution, just to make sure that we captured every detail that we could. And then this is the drawings. I guess I haven't really explained it, but the intention was then not just, okay, we scanned it, but for the masons to work and develop their project in the computer, lay out all the blocks ahead of time in the computer to make sure everything was going to work, rather than finding out on site or kind of a trial and error method. And ultimately, I believe when we gave our fee proposal for how much it would cost to scan it, their response was, well, if you guys think you're so good, then you come and scan it. If we find it useful, then we'll pay you. And we were paid, so it was very helpful to them. Now, this was something that I talked about with David that never actually saw fruition. But again, this comes back to not the technology itself, but where these technologies and whether people are aware of them and where they are in the kind of I guess the kind of procurement. But ultimately what David wanted to do was to take all these stones and to automate the process. So for those of you that don't know, when they're building, the stonemasons are building these stones, they make two-dimensional templates. So it's basically as the views. So if you're looking at the stone from one side, the view from this side, the view from the top and bottom, they draw those by hand. They cut them out of a resilient material. Traditionally, it's zinc, but today it's more of a kind of an acrylic plastic, flexible plastic. And then they use those templates to carve the stone. So what we talked about was to create an automated process where each stone could be created in a mason would kind of manually in the computer create the stone, but then there would be an automated process which could produce all the different views and output all the templates, and then have those templates sent to a water jet cutter or a CNC like this, and have that kind of whole process automated. So that's the kind of thing that we're interested in trying for this project. It was we got involved too late in the game, but thank you. That's my talk. Hopefully it lived up to expectations.